Hello everybody. You've just tuned in to Mathematics Term 1 End of Term Exam 2023. Let's do this.
Right. I have 16 questions to do apparently, and I spent 40 minutes doing 5 questions for my year 8s. That was 40 minutes recording time, which is 8 minutes per question. And since we have 16 questions, that would predict about a 2.5 hour video, and I do not intend on doing that. Oh great, we got some errors. As I said before, if anyone wants to donate money to get me a new computer, you're welcome. This computer actually has seen me through a lot of challenging projects that I've done. So let's be fair. But anyway, I need a new one. So if you want to donate a few $1,000, I'm willing to receive it. Okay, let's go. We'll go for question 2, right? So question 2, what is the problem here? Oh god. Again, I left my mouse in Ireland and I'm not buying a new one, so yeah. If you hear any like extremely loud clicks, I'm using the pad on my laptop. Anyway, let's go. I think I was to look at this question 2b. Work out the number. Again, all these solutions are up on Google Classroom. There were 80 players in Colin's sample. Work out the number of players who ran a distance of greater than 5.6 kilometers. Alright, so, well, first of all, where's 5.6 kilometers? It is right there, which is the upper quartile. It's the upper quartile right there. Now, the upper quartile represents what percent? Tile is the 75th percentile, because it's 3/4. So 3/4 of the data, or 75% of the data, is below the upper quartile. So how much is above it? 25%. So that means 25% of the players ran greater than 5.6 kilometers. So 25%. So how many players were there in total? 80. So 25% of 80 is 1/4 of 80, which is 20. So the answer is 20 peoples. Peoples, yeah, persons. 20 people. Okay, we go to question... Did you want me to do all of that? Jeez, maybe you want me to do all that. Let's have a look then. Work out the interquartile range. Well, each one of these gaps is 0.1, so that's 4.6. Or sorry, every 2 gaps is 0.1. So that's 4.6, 4.7, 4.8, 4.9. So we can see this is in between 4.8 and 4.9. So what number is halfway between that? It's 4.85. Upper quartile is 5.6. So the interquartile range, work it out. So that means show your workings. 5.6 minus 4.85. That is, because it's the upper quartile minus the lower quartile. Alright. Whatever that is, 0.75. Right, 0.75 kilometers. Alrighty. And then, I don't know if you want me to do it, I'll just do it anyhow. Compare the distribution. I mean, that was done. That was written down. You compare the medians, and then you say, one median is bigger, therefore the average distance run is bigger. And then you say, the interquartile range, if they're the same, or if they're bigger, whatever, just comment on it and say, interquartile ranges, or range for the second half was smaller than the first half. This tells us that the spread of the distances run was less. Okay, so it's always median, and that tells us about the average, and then the interquartile ranges, and that tells us about the spread of the data. Alright, question 8, also known as question 8. Here we go. I'm sick of doing maths. I never thought I'd say it. I've been doing it all day since 6 this morning, and it is now 7:15. Right, why did you ask me? I did this in the class. I did it with the girls. Alright. 20 men, 10 women, and 10 children in a competition. The mean score for the women is 15.6. Mean for the children is 9.2. Kevin says the mean score for all people is 11.2. Great. Work out the mean for the men. Okay, you might not know where to start. Let's do what we can. Mean score for the women is 15.6, and we got 10 women. So we can say for the total score for the women, I'm going to put a W for the women, or something resembling a W, subscript. So that equals what? We have 10 women, and the score is average is 15.6. So the total score that the women got is 156. Alright, now let's go for the children. Women and children first. Yes, always the way, huh? Women and children first. Men last. Right. The mean score for the 10 children is 9.2. So you can do this in your head, really. The total score for that the children got is 92. Between all 10 of them. The average then was 9.2. Right, so for all people, we'll go over a different color again. So the total for all. So I'll just put A for all. Subscript A is 40 people times 11.2, and that should give you 448. So the total scored was 448. So how would you get for the total for the men? Well, it's going to be the total scored. Oh, my computer is kind of. Yeah, minus what? It's going to be the total scored minus the women's score minus the children's score, and then that will give us what the men have scored. Alright. So let's go here. So I should do this in the calculator anyway, whatever. 156 plus 92 is going to be 248, right? 248, so 448 minus 248 equals 200. So the men scored 200, the women scored 156, and the children scored 92. So that proves that men are better than women, right? Because the men got higher. Yeah, they got higher. It's proof. Actually, it's not proof, because there were 20 men and 10 women and 10 children. So the men only averaged a score of 10, which makes them slightly higher than the children. Anyway, so there you go. The women performed the best. And work out the mean score for the men. Well, the mean score for the men is 200. That looks like a 6. Divided by 20. So as I said, that was 10. So it's 10 points, or whatever they call it. Alrighty. So now we'll move ahead to question number 9. Which, oh, do I have to do this? Kevin is wrong. The mean score for 40 people was actually, that was answered. Yeah, I don't need to rewrite that. Question 9. 25 students take a science exam in class A. 30 students in class B take a science exam. Let's do the same thing here. The mean mark for 25 students. So what was the total mark? The total amount of whatever, points, percentage, whatever. Let's go through it. So we're going to do the total. Sorry, my computer is a bit. Total for. I'm going to total A, okay, equals. So the total for class A is what? It's 25 times 67.8. So you should be able to do this based on the last question. It's just harder numbers. And then we're going to do, for the next one, for class B, we have the total for B equals, we have 30 students, but we don't know what their average was, or their mean as they call it. So let's just call it 30 times x, yeah. What's that equal at 30x? I better put it like that, the nice x, the stylized x. Now, alright, but we know that the total for 55 students is total for all students. So total for all is what? 55 times 72. Well, 5 times 72 is 360, because we know that from exterior angles of pentagons. So that should be 396 then, because it should be 360 plus 36. I shouldn't really be doing this in my head. Anyway, if you multiply by 100, that would be 6, 7, 80, and then divided by 4 to get 25. So it's going to be 1, 6, 9, 5, I'm going to say. Yeah, whatever. 1695. 1695. Let's go with that. Actually, I'm just going to get my calculator out because I don't want to make any mistakes to confuse you. 25 times 67.8. Oh look, totally right. I should never have even checked. No, it's good to check, even if you're like a mathematical genius. There you go. Cool. Now we have to work out the mean mark for the men. Yeah. So we know that what? I'm not going to keep changing the pen colors now. I'm just going to keep it. You got to be able to follow this at this stage. We know that 1695 plus 30x. Did I just really write that? Of course. That should be a 0 there, shouldn't it? There we go. Equals, just after I talked about being a mathematical genius, how embarrassing. Well, at least I saw it. Equals that. So how are we going to get the average for the men? So we're just going to solve for x. That implies 30x equals 3960 minus 1695. Alright. Well, that minus 1700 would be 2260, but we're doing 5 less, so it should be 2265. And so 30x equals that. So you just divide by 30 to get your answer. So that, oh, my computer's just really going crazy. If you divide by 30, you're going to get 750.5. 750.5, pure guess. Let's go. 2265 divided by 30. Jeez, I'm losing it. 75.5. What am I even talking about? 75.5. Right, let's just move on. That's that. Now question 10. Question 10. Why did you ask me to do this question? You asked me to do the most boring question in the world ever. Kelly records. Work out the number of teachers with a travel time of 35 minutes or more. Well, it literally says here, these are the travel times in minutes. Yeah. The table shows the information about these travel times in minutes. So these are the travel times. And you're looking for 35. Yeah. Upper quartile is 35. So that means that that represents 75. It's the same as the other one. 25% of the people are obviously take a longer time than the upper quartile. Yeah. So it's going to be 25%. It's the very same. 25% of 48. So it's 25% times 48. What's a quarter of 48? You should know that off the top of your head. 12. Now, work out, yeah. Don't just write down the answer. All the boys in year 9 who think they're really smart and you're not. Work out. You need to learn how to read and do maths. Right, now on the grid, draw a box plot. Alright, you should know how to do that by this stage. Least time. So we're going to put a line at 5, 18, 28, 35, 47. 5, 18, 28, 35, 47. So I'm just going to stick a line in here. There we go. If my computer plays ball. Right, so you put a line in. So it's 5. That looks like 5 to me. 18 is here. Miss Aoife probably has this done anyway. 28, 35. Where is that line? Here. And then 47. Boom. So that's that. You just put in the 5 points that are important to us. Just make 5, 18, 28, 35, 47. Yeah, and then you just connect the upper so it looks like that. It's that syringe shape. So you just connect them. Yep, and put. You see that? You know what a ruler is, people. Use one. You're big boys and girls now. Yeah, so there we go. We have a beautiful syringe here. There, put that in. So it's like you have the plunger and the plunger, you know what I mean? Yeah, just make sure it doesn't go over it. Who cares? That's it. Now, that's that. Job done. Right. So then you compare. So the median of this is lower than the median of that. That means the average time spent. What day was this? What's the difference between these? Monday. So the top one is for Monday, the bottom one is for Tuesday. Median is lower on the top on Monday. That means the average time taken on a Monday is less. And the interquartile range is way bigger on the Tuesday. That means the spread of the spread of data for time taken is greater on Tuesday. Alright. I'm sure that's what, let me see if it's it. Right, now, Questione 11. Right. Ken is X years old. Liam, that's my name in Irish, actually. I should have been named Liam. Anyway, Liam is X plus 4. Tina is 3X. Write an expression in terms of X for the mean of their ages. How do you get the mean of ages of anything? We have that sigma. The sigma. I know a lot of sigmas. Here we go. So sigma just means, remember, I'm going to put this in. If you don't know what it means, fine. But Sigma means the sum of ages. So it's the sum of ages divided by the number of ages. The number of I don't think you have to put of the number of ages. Alright, in other words, in normal language, it's Ken's age plus sum of ages. The sum of the ages, or the sum of the values, remember that? Sum of the values? Not valves, as it looks like there, it is values. Divided by the number of values. Let's just put the of in. Number of values, yeah, easy peasy. Sum of the values is what? It's x plus 4. I'll put the different ages in brackets so people can see what's going on. 3x. Alrighty. And the number of ages is 3. Alright. So we have x plus... why is this so weird? Alright, whatever. That equals 3x plus x is 5x. So it's 5x plus 4 over 3. That's bizarre, isn't it? It's not very nice. Whatever. They usually make it nice. They must have been lazy when they're making their question. 12b. 12b or not 12b? That is not the question. Alrighty. Blah 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 blah. Work out an estimate for the number of girls with a height between 133 and 157. I'm guessing that they are either the quartiles or the median. Oh, look at this. Of course, they are. So, 133 and 157. Right. Well, you can see straight away, right, that 133 is the minimum height, isn't it? It's the minimum height. So, straight off. And then 157 is the upper quartile. So this is going to be interesting. So the upper quartile, what percentage does that represent? That represents the 75th percentile. So 75% of the values are less than this. Now if we go back down, work out the number of girls with a height between 133 and 157. Huh. Well, what did I just say there? Sorry, this is going a bit crazy. We are on question 12. Right. You'll have to forgive me. Well, 75% of the values are less than that. So 75% of the values are between the lowest value and the 75th percentile. So it's going to be 75% of the total number, which is 80. Same crack as before. Huh? Well, let's do it. 75% of 80. Yeah. What's 25% of 80? 20. This is 3/4, yeah? 1/4 is 20, 3/4 is 60. That's it. Alright, 60 people. Right, next. 28. We're going way down. Lovely. I'm hoping this is a nice question. They've all been pretty boring so far. Oh, this one. Come on. Gotta be kidding me. I put out two beautiful solutions to this on in the solution book. All right, I'll do it both ways because they both deserve. I don't think I can say students' names on this because of like privacy. But yeah, one of my boys did a really good job. Let's call him Mr. S. He had a really interesting view of this. Now let's look at the white areas. Yeah. So how do we get the grey area? Well, if we get the area of the entire square, we're told it's a square. Yeah, we're told it's a square. If we get the area of the entire square, then what? Take away the 3 white triangles and we'll get the area of the grey triangle. That's what we want. Alright, let's mark in what we know. As always, it's a square, so that has to be 4x. If that's x, this has to be 3x. Now, what are these? M looks to be halfway up, but let's just double check. M is the midpoint of DC. So if that's the midpoint of here to here, this has to be 2x. And that has to be 2x. Right. So let's go for, call this triangle 1. So area 1 equals what? Half the base. Everybody should know this. Half the area of a triangle, I'll just put area triangle, equals half the base times the height. Half BH, or B times H over 2, however way you want it, they're all the same. So it's half of 4x times 3x. I love brackets, so I'm just going to use brackets. Alright, and then let's get the area of, what color do we choose? This, let's call it 2. So we're going to go area 2 equals half. Again, we 4x, but this time it's times 2x, and that equals. And then we'll get the little one. Area 3, so that's going to be half of 2x times x. Area equals half of 2x times x. Now, let's rock and roll here. We can just blast through these. Easy. Half of 4x is 2x. 2x times 3x is 6x squared. A half of 4x is 2x. 2x times 2x is 4x squared. A half of 2x is x. X times x is x squared. Done. Now, so we know if we get the area of the square minus the 3 triangles, yeah, we'll get the area of the grey triangle. So, what's the area of the square? Well, it's 4x squared, isn't it? That equals, because it's 4x times 4x. That's 16x squared. Alright, so let's do this. So we're going to have 16x squared minus 6x squared minus 4x squared minus x squared. Alright, let's do it. 16x squared minus 6x squared is 10x squared minus 4x squared is 6x squared minus x squared is 5x squared. Done. Dum diddy dum dum. Easy peasy. So that will be your answer. Alright. X squared, 5x squared. Alright, let's move on. Do you really want me to do this? Give an expression in terms of x? Oh, for the area. Okay, there's another way of doing this. If you really want me to show you, I'll show you. I'll show you. Your future minds will be better off for this. I hope some of you make some like amazing discoveries in the future, and it was all because I showed you this way, and it opened the door in your mind. Let's see. That's what I keep telling myself. Let's go. Let's just use that. Put it here. Now, there was an alternative way suggested by one of my year 9, Mr. S in year 9 boys. So let's set one. Let's have a go. So he said, if we were able to calculate the length of this line here, now this is, it is easier in a way, but in another way it's not. And then we're able to calculate the length of that line there. We'd have the base and the height of the triangle. So we could just go half the base times the height. And he said, like, would that work out to be the same? So let's do it. I'm going to call this line Y. Well, I'm trying to call it Y. My computer is not happy about it. Let's call that Y, and we'll call this Q. Alright? So we have Y and Q. So we know, well, this is a right angle triangle, isn't it? So to get the hypotenuse, we can say y equals the square root of, that's the hypotenuse of this triangle, 2x squared plus 4x squared. So it's going to be bracket 2x squared plus 4x squared. And that equals the square root of 4x squared plus 16x squared. And that equals root 20x squared, all under. Now, if you're very good at maths, you will know that root cancels out the x squared. So that equals root, well, if you want to, I'll split it up. Here we go. It's root 20 times root x squared. Alright? Yeah? And that equals root 20x squared. Don't be frightened, or root 20x. Don't be frightened by this. Root 20 is just a number. It's between 4 and 5 because 16 is, or root 16 is 4, root 25 is 5. So it's about, I know 4.5 squared is 20.25, so it's just below 4.5. That's all, it's just a number. Anyway, we have an expression for that. Now let's get Q. So if we get Q, we have Q, the sides of this little triangle are x and 2x. So we know Q is the hypotenuse of this little triangle. So we know Q equals the square root of x squared plus 2x squared. It's Pythagoras' theorem. So we know Q equals the square root of x squared, we don't need brackets for that because there's no number, plus 2x squared. Don't forget the squared number. So that equals, well, what's x squared? X, and 2 squared is 4, isn't it? So it's x squared plus 4x squared. So I just say x squared is x? Anyway, whatever. So that equals root 5x squared. So as you know from the top, we just skip this step. That equals root 5x. Root 5x. Now, we know that's root 5x, and we know this is root 20x. So to get this hypotenuse, oh, we don't even need the hypotenuse. What am I talking about? We need the area. So it's going to be half the base times the height. So we're saying the area, I'll put it in a different color. We're saying the area of the shaded region equals half the base times the height. Half the base is root 20x. Computer's getting a bit weird. Root 20x, I'm just going to put that in brackets, times the height, which is root 5x. Alright, so let's do it. That equals a half of, well, let's multiply these numbers first. Root 20 times root 5 is root 100. And x times x is x squared. What's the square root of 100? 10. And then we have x squared. What's half of 10? 5. X squared. That's it. Cloud it just to show that it is right. That's that. So And when you go back, yeah, you'll find that that is the right answer. Because up here, we also had 5x squared when we did it the other way. So you can do it either way, whatever. The second way is a lot harder, but it's a lot more interesting too. Let's go to question 40. I hope this video does not crash. Should I split it into? No, I'm not going to split it into. Question 40. What's wrong with what's the deal with question 40? Oh, come on. Again, all these are done. I did them this morning. And now I'm doing them again. And I taught them in class. So I'm getting sick of doing it, to be honest. Alright, let's go. We need to calculate the length of AC. So AC is that length. There. Where is the line? Come on. Yeah, there you go. So we need to calculate that length, basically. Cool. So how would we do that? Well, if we got this bottom length and we got that, we have the vertical length. So we need to figure out this bottom length. Right, how are we going to do that? I don't. When I actually do know because I did it this morning. But the first thing, like I did, the second I looked at it, I was like, right, any question I do, I pretty much just do what you know. So you don't need to figure it all out before you do it. Just start firing stuff in, you know, and then it gets easier to understand. So if we put a line across there, that helps us a lot. Because we know that this height is 9 minus 3. So because it's 9 minus 3, which is 6. So the height of that is 6. Now, do we know the width of this? That's the question. Do we know the width of it? Not yet, but we can, because that see this triangle? Let's call this E. AED. Not Arab Emirati dollars, but AED. It's a right angle triangle, right? And we know that's 6 and that's 10. So we can say this. I'm just going to call it. I'm going to call this X. So we know. So let's call ED that length X. So we know X squared. X squared plus 6 squared is equal to. So I know some of you can do this a lot faster, but some people mightn't understand. We know X squared plus 6 squared equals 10 squared. Right? So that implies we just want to get X, we don't care about the others. So we've got X squared equals 10 squared minus 6 squared. That implies, now do not just stick a root in there. If you put a root in there, you have to cancel the square. So instead of doing that, just write another line. X equals square root of, because it won't be mathematically correct, 10 squared minus 6 squared. And when you do that, this is a standard Pythagorean triangle. In other words, you get whole numbers on each side. When you do that, you get 64. So it's root 64, which is 8. So we know that this is actually 8 now. Alright, so that means we know that that's 8 now. So now look at the triangle ABC. Remember them? The ABCs? Back in the day. Here we go. So we know in that triangle we have 9 squared plus 8 squared equals AC squared. I'm going to use a different color. I'm just going to say I don't like using AC. Let AC equal whatever y. I'm just going to call it y. So we can say y squared equals 8 squared plus 9 squared. That implies y equals square root of 9, or whatever, 8 squared plus 9 squared. 8 squared is 64, 9 squared is 81, so it's the square root of 145, which should be just a little bit higher than 12, because 12 squared is 144. 3 significant figures. Okay, let's do that. Now guys, you have got to get these right, because that's a mark. You lose 20% if you lose that mark. That's huge. Please get these right. Right, so it's the square root of 145, right? I think it's 12.2 or something. Let's do it. It's not, it's 12.0 or something. Right, let's get it on in here. So it's root 145, so it's 12.0159. So it's 12.0159. Now, sorry, 12.04159, excuse me. I'll change that to a 4 now. It's 12.04159. Now, we have to get the third significant figure. The rule with significant figures is 0 cannot be the first significant figure. But after that, it doesn't matter. Okay, so the first significant figure is the first non-zero number. Okay, which is this. That's the first. That's the second. This is the third. It's fine, 0 being the third. It just cannot be the first significant figure. Okay, so that's the third significant figure. We look to the right. It's 4, so we don't round up. So the answer is going to be 12.0. Don't put it as 12. It's 12.0 because you have 1, 2, 3 significant figures. You have to show them. Alrighty, let's go to 48. If you're still with me at this stage, give me a hello in the comments section. Isosceles triangle. Alright. So first thing that jumps out to me, I'm not even looking at the question. I'm not important right now. Parallel lines. So we're going to have a Z shape, yeah? And I think I marked that in the solutions. Z shape. Oh, look. Yes. There. And we'll go down here. We have our Z shape along the parallel lines. A thing of beauty. There we go. Done. Now, what does that tell us? It is going to help us a lot, actually. Work out the size of angle Y. Okay. Now, what are we told here? What are we told here? BCD and ABD are isosceles triangles. And we're told this as well. We're told BC and BD are equal. And we're told AB and AD are equal. So let's do that. So I'm going to put in AB and AD. So this is A. So AB, yeah, and AD are equal. Alright, I'm just going to use a different color here. Maybe you could use 2 lines if you want. BC and BD. So that and that. And that and that are equal. Alright. Well, that's 120. You must give reasons for your answer. Oh, I'm sure Miss Aoife did that. No? Oh, I can't stand these questions where you have to give reasons. Anyway, this is isosceles. So what's that? That angle is going to equal that angle. Ready? So I'm going to call this angle ADB. ADB. ADB and angle ABD. Right, so let's do these angles first. So what are we doing? We know 180 degrees. So let's just call it, can I call this X? X and X. We know 180 equals 120 plus 2x, because 180 degrees in a triangle. And this is isosceles, so these are equal. So that implies 180 minus 120 is 60, so 60 equals 2x. That implies x equals 30 degrees. Alright, so you have to give a reason, unfortunately. Alright, so you can say, I'm actually just going to type this, I'm not writing this out. And I don't even like typing it. So say, angles at the base of an isosceles triangle are equal. That's one. And the second reason was angles in a triangle sum to 180. I think if I Alt 0276, is it? No. Alt 0176. Yeah. So if you just ever want to do the degree symbol, you press Alt, ALT, keep it pressed down, and then press, what was it again? 0276 on the number pad. That gives you the degree symbol. Since I'm a terribly interesting person, aren't I? Yeah, let's do it again. I'll just check it. Alt 0, is it 276 or 17? Sorry, Alt 0176. Yeah, there you go. Anyway. Cool. So there are two reasons. So that's reason 1, and this is reason 2. Now, what else do we need to get? Well, we have our Z shape, yeah. We have our Z shape, so we know that this angle here and this angle here is the same, because they are here and here, they're corresponding angles, right? Or alternate angles. So we can say angle DBC, or CBD, let's say CBD. So CBD is 30 degrees. Why? It's 30 degrees. So then just give your reasons. So you could say alternate angles, yeah, are equal, and that's it. So alternate angles are equal. So I don't like it when we have to give the I'm sure these were given in the thing, in the solutions. Did I do this question in the solutions? I did. Alright. So what else do you want? Why? So you know, this is an isosceles triangle. You know this is also, come on. You know this is also y. Yeah? We know that's y. So I'm going to put it in black because it's easier to see. Color coordinate. So you know that's also y because it's an isosceles triangle based on isosceles triangle. So you could say y equals, so x is 30, so y has to be 180 minus 30 divided by 2. So let's do this. So we can say y so 180, y equals 180 minus 30 over 2, and that equals 75 degrees. Okay, so give your reasons. Again, it's the same, it's the exact same as this. Angles at the base of an isosceles triangle are equal, angles in a triangle are 180. Alright, done. I'm sick of that question already. I mean, it's a nice question if you didn't have to give the reasons, you know what I mean? Question 50. We're getting there. How long have we done? Guys, you're taking my time. I'm looking forward to all those donations you're going to give me. I think it's all going to be worth all the thousands of dollars you're going to give me. Right, let's go to question 50. Here we are. Beautiful question. I did this in class. Now I'm going to have to do it again. Right, guys, you gotta, they're not giving you information for fun. Right, first thing that jumps out, regular polygon. Formula for total angles inside the total I noticed the interior angle. I'm just going to say total interior. Okay. The total of the interior. Have a rogue capital here. I'll make it a small lowercase. There you go. Total interior angles. Total of the interior angles, or the sum of the interior angles, equals what? 180 times n minus 2. Now, each interior angle, because it's regular, we can just divide it by the number of angles, or the number of sides. Each interior angles equals 180 times n minus 2 over n. And what's n? Well, there you go. N equals 12. Since this is regular, we know that this is isosceles. Yeah, because all the side lengths are the same. So let's go each interior angle. So here and here. So let's do it. 180 times n minus 2, 12 minus 2 over 12. So that equals 1800 over 12. That equals 150 degrees. So you know that that angle there is 150 degrees. With, what am I saying? Almost fell into the trap there. I was like, this doesn't make sense. This angle here is 150 degrees. Alrighty. Now, if that's 150, this is an isosceles triangle. These two angles have to be the same. So what's left? 180 minus 150 is 30. So that's 15 degrees. That's 15 degrees. Show you're working. Don't do it in your head. So write down STR, angle STR. So you do 180 minus 150 over 2. That equals 15 degrees. Alright, done. 15. Move on. Questione 51. Thank you so much to the students who gave me tons of questions. Really, oh, not this one. I don't like this question because it's not drawn. This is warped. This should be slightly angled down. I have a similar question, really similar, except these are just shifted over to this side. I did 2 workbooks on polygons, and in that one they are actually drawn accurately. It looks much cleaner. Anyway, because this actually fools you. You could be fooled into thinking that should be a straight line, and you can use this. You can actually use this triangle then, because you get that angle there, and you get that angle there. Then you can get the interior angles of the triangle, and then that allows you to get this angle. Then it's vertically opposite, but you can't do that because these are not. They both should be angled down. It's very deceiving. I don't like it. Anyway, what do we have? I'm not even looking at the question. Whatever. We can just write down what we have. Regular octagon. Regular pentagons. Alright, so let's go. Regular octagon. We need to get x. Okay, let's start filling in what we know. Regular octagon. So we go, I'm going to call it int. You could just say angle, really. Do I only need to say interior? Int angle. I'm going to put an O for octagon equals 180 times, remember, n minus 2, which is 8 minus 2 over n, which is 8. So that is 1080 over 8, and that is 135 degrees. Coolio? So you know all these are 135. Now, are the ones up here going to be that important? Probably not. But let's just throw these ones in. 135. I'm not bothered putting the degree sign in. We know it's a degree. Alright, now let's get the pentagons. I'm actually going to use I'll try this kind of peach color. Alright, so let's go for the pentagons. We're going to I'll do this a little bit stronger. So for the pentagons, we're going to do the same thing. So int angle. Again, you don't have to write it like this. I'm just doing it. And subscript P for pentagon, just so I know. So if somebody looks at this, they're not going to look at it like it's Chinese, you know, unless they're from China or Taiwan or somewhere. Then they'll have no problem. Anyway, regular pentagon. So it's going to be 180 times, how many sides on a pentagon? It used to be 5. I think it's still 5, if I'm not very much mistaken. Divided by 5. So 3 times 180 is 540. And that's over 5. So that equals 108 degrees. Okie dokie. So we know that, let's do it here. So we know that that angle there is 108 degrees. Let me zoom in. It's not, I should use a stronger color really, shouldn't I? That one. Yeah, so we know that angle there is 108 degrees. Haha. But if that's 108 degrees, then what's this angle? It's going to be 135 minus 108. Yeah. So I'm going to call this Y. And if that's Y, this is Y. Because we are told that these are identical pentagons. So we know this is isosceles. Isosceles triangle. So let's do it. So to get Y equals 135 minus 108. And that equals what? 27 degrees. And don't be afraid to put in your own letters, you know. Put in your, as long as they're not somewhere else in the diagram. Put in your own stuff that shows that, you know, take ownership. It's your question, it's your worksheet. So they're 27. So we know 27 plus 27 plus x equals 180. So let's do that. So we know 180 degrees, yeah, in this little triangle equals x plus 27 degrees plus 27. You don't have to put the degree symbol in here, I'm just showing you where it comes from. That implies 180 minus 54, because 27 plus 27 is 54, equals x. That implies x equals 126 degrees. Coolio, done. Right, let's move onwards and upwards to question. What was that, 51? I hope that was 51. Yeah, we go to 53. Did I just go by it? No. Alright, here's 53. Not this one again. I've done this twice now in the last day. In the last 30 whatever hours. In about the last 30 hours I've done this one. This is the third time. Alright, regular pentagon. Alright, let's go. Let's do the interior angle. You don't really need to say interior. Interior angle. I'm just going to put P for pentagon. Equals 180 times 5 minus 2 over 5. And we already know that's 108 degrees. So if you hear any noise, it's my adult housemate, adult teacher housemate, who plays computer games all weekend while I'm helping my students, while he sits there eating junk food playing computer games. So if you hear that noise, that's what it is. So if you study 7 years at university like me, get a master's degree in maths, bachelor's in engineering, teacher qualification, 7 years, you too could live with some random person who plays computer games all day. Just think about that. Is that inspirational? Anyway, let's plow on. So we know they're all 108 degrees. Now, what else do we know? We know that this is 90 degrees. Alright? Because we're told ACFG is a square, ACFG is a square. Okay. Work out the side. There's a couple of ways to do this actually. Work out DCF. So we need to look for this angle here. DCF. How are we going to get that? Well, look at this triangle. It's isosceles because this is a regular pentagon. So if that's 108, this angle here is going to be what? It's going to be 180 minus 108 divided by 2. So show your work. So write down 180 minus 108 equals whatever, 72 degrees. So then you say 72 over 2. Or you could just put all this over 2. You know what I mean? Whatever way you want to do it. So you say 36 degrees. So you know that that is 36 degrees. Oops, a daisy. That's 36 degrees. Now, let's come inside here. Now, if that's 36 degrees and this is 108 degrees, it is a bit congested here, but we'll persevere. What angle would that be? Because we know this is 36 and that's 108. So this has to be. So you got to show your work in here. Even I'm tempted to just write it down. But let's look at this. So we can go 108 degrees minus 36 degrees. And that's also 72 degrees. There's a couple of ways you can do this question though. That's 72 degrees. Okay, but that's a right angle down there. So we know 90 degrees minus 72 degrees is going to give us the green. I shouldn't put a green actually because I want a color coordinate. Pink. So we know 90 degrees, which is this, minus that will leave us with this. Minus 72 degrees equals 18 degrees. So that is your answer, 18 degrees. Is that alright? Do they have the degree symbol? Yeah, done. Alright, let's move. We've only 4 left. Although somebody asked me, I have 5. Somebody asked me another question. I had 17 questions. 54. Do I really have to do this? Right, straight away, regular octagon. Let's use that information. I'm just going to write out angles, angles O. So equals what? 180 times n minus 2, so it's 8 minus 2 over 8. So you're going to get 135 degrees. Alright, so we know that this is 135 degrees. And we know that that is 135 degrees. Now, we know that's the same size as that. Is the same size as that. So we know let's just call it. We have to show that angle CDJ is 135. Is what? Sorry, CDJ. CDJ. We have to show that this. Let's call that X. We have to show that that is 135. Alright, fair enough. Fair enough. Well, let's do it then. Let's call that Y and let's call that Y. Well, they're identical, yeah? Because these are identical. So, we know. What's the sum of all the angles in a... look at this four-sided shape, a quadrilateral, 360. Let's write down 360 equals 2y plus 135 plus 135. Yeah, 360 is that plus that plus that plus that. So that implies, so again, I know a lot of you can do this in your head. I don't care. This is for everybody. 135 plus 135 is 270. So we're going to bring that across, becomes minus 270 equals 2y. That implies 90 equals 2y. That implies 45 equals y. This is good because 45 has a distinct relationship with 135 because added together they give us 180, and also 3 times 45 is 135, 4 times is 180. So we just figured out that this is 45 degrees. Yeah, so we know x plus 45 is 180 degrees. So let's just go, thank God we don't have to get the reasons for this. So we know x plus 45 equals 180 degrees. That implies, I should put 45 degrees there. That implies x equals 180 minus 45. That equals 135 degrees. And that's what we had to prove, isn't it? Which, just call it CDJ. It should be literally, it should, in the UK they do it, I don't like it. It should be angle CDJ. CDJ could be a triangle. I don't like the way they do it. It should be an angle there. Anyway, that's whatever. And we prove that. So you can put QED. My teacher used to always say he was a brilliant teacher. A really good, brilliant mathematics teacher. QED is Latin. It means quod erat demonstrandum, which means it has been demonstrated or it has been shown. You do that at the end of a proof, but nowadays they don't do that. Nowadays, at the end of a maths proof, they do like a square. They do a square and they do like a squiggly line in it. But I like QED. QED is way better. Whatever. But you can. I just do the two of them usually. Anyway, let's march on. Questione 55. The relentless march. Come on. Alright. What do we have to do? Show polygon P is a hexagon. I'm assuming it means regular hexagon. Did I just press print? Sorry. So we have to show that polygon P is our hexagon. It should be a regular hexagon. Now, if polygon P is a regular hexagon, what does that mean? What do we know about regular hexagon? All the angles, yeah? So for a hexagon, I am going to say regular. This question should stay regular. Unless it says they're all regular up above. I don't know. Does it say that? Yeah, it does. It does say it's a regular polygon, so fair enough. Fair enough. It does say that. But you have to watch out, you know. We have to be on the ball. Alright, so regular hexagon. We know the internal angles. I'm just going to say angles. I don't care about the exterior right now. We only care about the inside, don't we? Don't care what's on the outside. Regular hexagon angle. Yeah, equal 180 times n minus 2. 6 minus 2 over 6. And that equals, well actually, you know, there's a couple ways you could do it. 180 divided by 6 is 30. 30 times 4 is 120, yeah. Or you could say 180 times 4 is 720 divided by 6 is 120. Whatever way you want to do it, doesn't really matter. 120 degrees, so we need to prove that. So you could say to prove. That's what we have to prove. So we're going to use our little QED and square again. Can't wait. Now, let's go. Well, this is a square. Speaking of squares, that's a square. So that's 90 degrees. I'm going to focus over here. That's 90. So what else do we know? This angle here at B. Yeah. So we can say regular polygon. Polygon? it's the 12-sided polygon. I'll just say the name. It's called a dodecagon, okay? Dodeca. Do means 2, deca means 10, so it's 2 and 10. Dodecagon. Gon means sides. Dodecagon. And in 3D, as a 3D object, an object with 12 faces is a dodecahedron. So hedron is for faces, they're 3D. Okay, so a regular, I'm going to say dodecagon because we're so technical. Dodeca. Decade, December. December used to be the 10th month, you know that. Said that about 50 times this year. Dodecade, decagon. Okay, that should be, yeah. Alright, regular dodecagon. So just color it. Yeah, so let's just get on with it. So we have what? We have this dodecagon. How do you get the interior angles of a dodecagon? That's the question. The answer is this. You use this formula, yes? So let's go and use that. So we're going to have 180 times 12 minus 2 over 12 this time, right? So let's do that. So go 180 times 12 minus 2 over 12. 10 times that is 1800. So it's 150 degrees. Alright, so you know that's 150 degrees. Oh look, we have 150, 90, and then this thing. And that makes a circle. And what are the angles around a point, also known as a circle? What do we call this? X. Yeah. So we know X plus 90 degrees from the square. X plus 90 plus 150. So I'll just put these, I'll color coordinate these so I can see where they come from. Plus 150 equals 360. You know that, yeah? All them three added together equals 360. That implies, well, 90 plus 150 is 240. 360 minus 240 is 120. X equals 120 degrees, which we had to prove. Here we go. My favorite, Q, E, D, quad erat demonstrandum. Oh, look at that. I've never done that before. Beautiful. Let's leave it in. Pretty cool. And we'll put the tail of the Q in. QED, it has been shown, or it has been demonstrated, it has been proven. I'll do a little box. That's it. We move on to Questione 55. 55, we're done it. Okay. 62, I've been asked to do 62. I definitely did that this morning. Well, I definitely did all of them, really, didn't I? 4x, I'm just going to bring this down to the next line. Not cloud. Excuse me. Delete. I have to go G. Right. So I'm just going to bring this down. And I'll put it here. Alright, now, so we got this, question 62. Alright, so we're looking for perpendicular to L, yes. Now, L has this equation, but we want that in the form y equals mx plus c. That's the way we like it. So let's rearrange it. So we're going to have y equals, that comes across, comes minus 4x. Minus 4x plus 7. Alright. Now, line perpendicular to L. What do we know about perpendicular? the gradient of a perpendicular line. We have to find the equation of a straight line perpendicular to L. Well, any line perpendicular to L, its gradient is the negative reciprocal. What does that mean? It means you invert the number and you change the sign, because the negative reciprocal multiplies by a number to give -1. The product of a number with its negative reciprocal is -1. So, alright, if you hadn't heard that before, you might be like, wow, what's he talking about? Doesn't matter for now. You have a test coming up, so just learn this. For a perpendicular line to any line, so perpendicular, so you could put perpendicular line. So for a perpendicular line, we're going to have y equals m. So m is going to be, you invert this, that means you turn it upside down, so it becomes 1/4, and you change the sign. So you just leave it as, or you just leave it as positive, yeah? You just make it positive. We don't know where it crosses the x-axis, because y equals 1/4 plus c. 1/4 x plus c, what am I talking about? I'm going to move this over, actually, if I can. Yeah. So y is 1/4. I should put x there, really. Well, not really. It should be there. 1/4 x plus c. Okay. So instead of m, we just have 1/4. Turn that upside down. Change the sign. All right. Now we need to find what c is. We know that this line crosses the y-axis the same, but we don't know where this one does. So what we do, we have some information. So for all these questions, you need the gradient, which you can get really easily, and then you need a point. Now sometimes they make you work for that point. They say it goes through the midpoint of these 2 points, and you have to find the midpoint, right? Or it goes through the origin. The origin is 0, 0. But here we're given the point, which is kind of usually what they do. So we know that this is x and this is y, and we know that line passes through these, so we can say y. So we have, I'll just rewrite it so it's nicer. Y equals 1/4 x plus c, right? I'm just rewriting it for no reason. Then, so x is -8, so I'm going to say y equals 1/4 of -8 plus c, and y is 3. Yeah? So we just replace y with 3 and replace x with -8 minus 8. So that implies, yeah, whatever. 3 equals -2. 1/4 of 8 is 2, so 1/4 minus 8 is -2. Let's see. That implies 5 equals c. Alright, bring that across, comes positive. Alright, so we just go into our equation and stick that in. So we know y equals 1/4 x plus c, which is 5. Boom, done. Question 66. What is question 66? Same crack, but this is actually easier. Alright, let's do it. This is actually easy, to be honest. I shouldn't say that. I just mean it's once you see this, you'll get it every time. That's what I mean. And nothing is easy if you don't know how to do it. Let's go. Let's go, champ. Let's go, champ. Computer, please do not freeze, because I've done. How long have we done? An hour and 20. Alright, probably take me an hour and 20 to upload this to. Anyway. A is the point with coordinates 2, 10. B is the... Alright. Gradient is 4. Well, alright. Find out what D is. Find the value of D. Well, what's the formula for gradient? Gradient, M equals y2 minus y1. Remember? The rise, so that's the change in vertical height, over the run, which is the change in horizontal x2 minus x1. Alright, Or you could actually do y1 minus y2 or x1 minus x2. It works out the same. It will always work out the same. All right, let's rock and roll. I'm gonna say this is x1 y1 and this x2 y2. How imaginative. y2 should be a 2. All right, go. So y2 minus y1 is d minus 10 over 5 minus 2 equals 4. That implies d minus 10 over, oh come on computer, don't do this to me now, we're nearly finished, over 3 equals 4. Right, that implies, somebody can do this in your head, d equals, oh sorry, I don't want to jump too far ahead for you. Let's say d minus 10 equals 12. That implies d equals 12 plus 10, which is 22. Done. Alright, I have been asked to look at quartiles from a cumulative frequency graph. Alright, I'm going to pause this. Okay, we are back. So this is from the averages and cumulative frequency booklet that I gave you guys. And you can see that this is question 12. Okay, so I just re-plugged in my pad here. It's gone a bit crazy. Anyway. The cumulative frequency graph shows information about the monthly rainfall in millimeters in the United Kingdom during 120 months, which is 10 years, in the years 2001 to 2010. Alright, great. So this shows the rainfall. Right. Use the graph to estimate the number of months which the rainfall was less than 50. That's going to be easy, isn't it? Rainfall is less than 50. So you go where the rainfall is 50. Now, each line, you can see here, well, let's go to start. Here to here is 20. So we've 5 lines, so each line is 4. So 50 is going to be right, well, obviously right in the middle of 40 and 60. Again, this is going to be an estimate. So it just depends how accurately you draw your lines, really. So, yeah, I mean, there's going to be a slight variation here. Well, what's that? Right, this is 20, so each of these is 2. So it's 2, 4, 6, 8. I mean, I don't know. You could go with 9 or 10 here, couldn't you? Oh yeah, if this is right in the middle, let's just draw our lines more accurately. Yeah, that's better. So it depends how accurately you draw your lines, really, doesn't it? So if that's right in the middle, yeah, it's gonna be 10. Yeah, boom. So just on the button. Yeah, it's right in the middle. So it's going to be 10. So we have, this is the cumulative frequency. So it's going to be 10 months had rainfall less than 50. Yeah? So, because that's 10. So 10 months had rainfall less than 50. 10 months. Come on. There you go. There you go. Now, next. Use the graph to find an estimate for the median. We always go on the vertical axis. Yes, always the y-axis, the vertical axis, always. Now, what's the highest value? 120. So the median is going to be half that, which is 60. So the median is going to be here. We're going to go across. Let's go a bit more accurate. Yeah, we'll get another line. It actually hits it like, it kind of hits it in the middle of them. Let's draw it. Yeah, it's right down the middle. So we know that we have 1, 2, 3, 4, 5. So each of these is worth 4. So this is going to be 90. It's right in the middle. So we know that the median is 90 millimeters. Draw those lines in, guys, nice and neat with rulers. Does it give the units here? Yeah. Find an estimate for the interquartile range. Now use the graph to find interquartile range, the upper quartile minus the lower quartile. Think of it as the upper quarter minus the lower quarter. What's the lower quarter? Well, a quarter of 120, or 25%, which the lower quartile represents. So I'm just going to put here, look, I'm just going to write this in for you so you understand it. Median. Okay. Now to get the lower quartile, a quarter of 120 is 30, which is here. And again, it's your paper, so you could write in 30, over 40. What am I saying, 40? 50 is here. And 70. Just to give you, you know, an idea of what's going on. There you go. Now, let's continue down. That one doesn't look too good, does it? Yeah, there you go. Now, this one looks beautiful. On the ball. We just go down. Bang. Oh, that to me looks like 64. And then 2 is 66. So I'm going to say that's 66. The lower quartile is 66. So I'm just going to put LQ here so you know what's going on. Come on. What's up? There you go, lower quartile. Now we'll do the upper quartile, which is obviously 3/4 of 120, which is 90. So we go to 90, go across, hit our target, boom. And we go down to, looks like 116 to me, because it's 4 less than 120, so it's 116. So I'm going to say 116 minus 66. So write that down. Write down those values. 116 minus 66 equals 50. So 50 millimeters. Alright. That's pretty much it. All of them are like that. They're all the same. I put videos there. Alright, draw a cumulative frequency graph. Okay, I'll do this one. So this is Questione. Oh. Where's that gone? Work out, alright, let's do this one. Question 11. Work out an estimate for the total weight of 80 parcels. So now, estimate is the key word. Because you have 8 parcels, right? We've 80 parcels. 8 of them are between 0 and 2 kilos. Well, all 8 of them, they could be 1 kilo. All 8 of them could be a half a kilo. Or we could have 1 is a half a kilo, 1 is 1 is 1.4, 1.8. We don't know. So as an estimate, we just go right in the middle. So go in the middle. So you can literally write down MF, the middle times the frequency. Or if you want, you can write the middle is blah blah blah. Middle is, right, I'll just do it for you. I'll do it for you. You can say middle, and then you can say frequency. It doesn't have to be beautiful, you know. It's not. You don't have to be Leonardo da Vinci on it. But with graphs and stuff, you do have to pay attention. The middle of 0 and 2 is 1. Middle of 2 and 4 is 3. Middle of 4 and 6 is 5. Middle of 6 and 8 is 7. 8 and 10 is 9. And the middle of 10 and 12 is 11. Now the frequency, well, we don't need to put that there really, do we? Let's just type in, we have the frequency, it's MF that I need to put in here. Excuse me. Come on. It's MF. MF. So then we do MF. 1 times 8 is 8. 3 times 14 is 42. 5 times 26 is 130. 17 times 7 is 119. 90, 55. Alright, so now to get an estimate for the total weight, let's just add these up. Alright, 8 plus 42 is 50, plus 130 is 180, plus 119 is 299, plus 90 is 389, plus 55 would be 444. Am I right there? I'll just do it by calculator. 8 plus 42 plus 130 plus 119 plus 90 plus 55. Yeah, 444. Sweet. Now, complete the cumulative frequency table. So let's go. Cumulative frequency. Okay, so basically we're going to get these numbers. I'm going to get these. And I'm going to... Oh no, it's these numbers that we're looking for. Alright? These are the ones we're looking for. Now, cumulative frequency. Come on. There you go. So, this is the table from above. Well, we got twins here. Come on, man. So this, we have the table from above here, and we're just going to populate this this little table here with that information. There we go. Now, so we have to get the cumulative so the cumulative frequency, notice the difference between these tables, this from 0 to 2, 2 to 4, but this is always from 0. So if you had 8 from 0 to 2, it's just going to be the same here. Now from 0 to 4, well, that's from here to here, which would be 8 plus 14, which is 22. 0 to 6 would be from here 0 down to 6 would be 8 plus 14 plus 26, so it's 22 plus 26, which is 48. 0 to 8, you're going to add 17, which is 65, and then you add 10, which is 75, and then you add 5, which is 80. Now, we're always going to go from the end value. In the future, you'll do stuff where you go from the middle, but not with cumulative frequency. You always go use this as your x coordinate. In future, with different graphs, you won't do that, but with cumulative frequency, you do. So you're going to go, okay, I can't really see. I'm going to work backwards. So I'm going to go 1280. So go to 12 and you go to 80. Oh, it's like whatever there, and then you're going to go 75, 10. So 75, 10. So whatever 10 is, 10, 75. Geez. Well, each of these is 2. So 75. 7.5. Alright, so I'm just going to go over. I'm going to go 1, 2, 3, 4, 5, 6, 7.5. It's going to be in there. Alright. Because 7.5 times 2 is 15. So that's 60 or 15. Alright, 865, 648. So 865. 860 and 5. So we've got 2, 4, 5. And 648. So we're going to go down 58, 56, 54, 52, 50, 48. It's here. Alright. And then we have 422 and 2, 8. 422 and 2, 8. 1, 2, 3, 4. Now you don't have to connect this to the end. Now, bear in mind I am not a great artist, and I'm on a kind of device that doesn't allow me to be a great artist either. So you try to draw a curve. Do not connect these with straight lines. You have to you kind of draw a curve. You have to use it. That's not great, is it? You have to use artistic license here. So I'm actually just going to delete that. Right, let's see. I mean, this is the most stressful thing I did all night. You're going to have some kind of a curve like that, right? It's going to be something like that. And that's it. I'm hoping the answer looks like that. And that's that. Okay, guys. I'm going to leave it at that. And, yeah.
See you next time, kids.
See you later. Have a good one.